So we've done graphs of sine, cosine, and tangent. We've done graphs of inverse functions. We have yet to do the graphs of reciprocal functions. So that's what this is going to be about, graphs of reciprocal functions. And I'm going to promise to try and keep it short. All right, we are going to start with secant. Cosecant. Y is equal to the cosecant of x. And remember, this is the same thing as 1 over the sine of x. Okay? And just like in the past when we've done these, we're going to use the unit circle to help us figure some stuff out. So here's my unit circle. 1, 0, 0, 1, negative 1, 0, and 0, negative 1. Okay, and we're going to graph this just like we did with all of our others. So I'll put my axes. Here's x, here's y, 2 pi, pi, pi over 2, 3 pi over 2. And the negative, I'm going to go to negative pi. I'm not going to go all the way. Okay, so let's go ahead and figure out some of our biggies. All right, let's figure out 0. The cosecant of 0. Well, the cosecant of 0 is 1 over the sine of 0. But the sine of 0 is 0. So this is undefined. And just like with tangent, where we had our function undefined, we had an asymptote there. So I'm going to have a vertical asymptote at x is equal to 0. It's a little hard to see because it's on the y-axis, but it is an asymptote. Okay. Now let's check pi over 2. The cosecant of pi over 2 is 1 over the sine of pi over 2. The sine of pi over 2 is 1, and 1 over 1 is just 1. So over here at pi over 2, I am up here at 1. Now we can go ahead and do pi. Let me extend my page. So now I'm doing the cosecant of pi, which is 1 over the sine of pi. The sine of pi is 0 though, so you get another undefined. So at pi, I'm going to have another asymptote because it's undefined there. I can also do 3 pi over 2. So the cosecant of 3 pi over 2 is 1 over the sine of 3 pi over 2. That's going to be 1 over negative 1, which is just negative 1. Sorry. So at 3 pi over 2, I'm here in negative 1. Okay. And 2 pi is the exact same thing as 0. So since I had an asymptote at 0 degrees, I'm going to have the same thing at 2 pi. Okay, and notice I'm getting asymptotes at every integer of pi. 1 pi, 2 pi, I would have an asymptote at 3 pi, 4 pi, 5 pi. The same thing is going to happen over here in negative pi. I'm also going to have an asymptote. And negative pi over 2 is the same thing as 3 pi over 2. So over here at negative pi over 2, I am also going to be at negative 1. Okay, now we got to fill in what's actually going on between all of these asymptotes. All right, let's be smart about this. Let's take a look between pi over 2 and pi. So as I go from pi over 2 to pi. As I go from pi over 2 to pi, notice that my signs, my y values are getting smaller. All right, at pi over 2, my sign is y, and then my y values keep getting lower and lower until I'm at 0. So if you think of cosecant, that has sine in the bottom, all right here. So my numerator is 1. It stays 1, but my denominator keeps getting smaller and smaller and smaller as I go from pi over 2 to pi. 1 divided by something that's getting super, super small is super, super big. So as I go from pi over 2 to pi, I keep dividing by something that's super tiny, so this shoots up to infinity. Okay, the same thing could be said is if I started at pi over 2 and I went back to 0. Okay, my y's are going from 1 down to 0. They're getting super, super tiny. So as I go from pi over 2 back to 0, my denominator keeps getting smaller. So this is shooting up to infinity. So this looks like a little cup, kind of, shooting up to infinity. Okay, now we can take a look between, how about 3 pi over 2 and 2 pi? So going between 3 pi over 2 to 2 pi. Okay, when I look here between 3 pi over 2 and 2 pi, again, my signs are getting, the distance for my signs is getting smaller. Okay, so at 3 pi over 2, I'm all the way down at -1, and then I keep getting closer and closer to 0. So what I'm dividing by is getting smaller. And when you divide by something small, it's getting really, really big. Okay, but you need to be careful because even though it's getting small, my signs down here are negative. Okay, so down here I've got 1, and then my signs down here are negative, and I'm dividing by something that's getting super, super tiny. Okay, it's negative because I'm in quadrant 4, but I'm still getting super, super small as I go from 3 over 2 to 2 pi. Or 3 pi over 2 to 2 pi. So I'm shooting to infinity, but because I have that negative, I'm actually shooting to negative infinity. So this is going to shoot down like this. And the same thing is going to happen over here. And then the same thing is going to happen over here. Okay, so this is what our graph of cosecant looks like. This is what the graph of cosecant looks like. All right, you will notice that the graph of cosecant and secant look very similar, but if you know where to put the asymptotes and the ones, that should help. Okay, when I'm up here at +1, I'm making smiley faces. When I'm down here at -1, I'm making frowny faces. You just got to make sure you know where to put the asymptotes. All right, if I do the graph of y is equal to secant x, all right, I'll draw my graph right here. X, y, 2 pi, pi, pi over 2, 3 pi over 2. Here will be -pi, -pi over 2. Okay, secant is y is equal 1 over cosine. So we are going to have asymptotes wherever our cosine is going to give us 0 because that's our denominator. Well, cosine gives us 0 at pi over 2 and 3 pi over 2. And the same thing is going to be over here where it's negative. So the asymptotes aren't at the pi's anymore. They're at the odd pi over 2's. Okay, so that's a big difference between secant and cosecant. So now let's go ahead and figure out 0. All right, let's figure out what's going on at 0. Well, 1 over the cosine of 0, the cosine of 0 is 1, so you get 1 over 1, which is 1. So at 0, I'm up here at 1. Okay, and we can go ahead and prove this again if you want, or we can kind of think, well, since previously, if you look at the graph of secant, when I was up at 1, I was positive 1, I had a positive quadratic, I was a smiley face kind of. The same thing's going to happen here. I'm up at +1, so I'm going to go to positive infinity. I'm going to have a smiley face. If we look at pi, I've got y equals 1 over the cosine of pi. That's going to give me 1 over -1, which is -1. So at pi, I'm going to be here at -1. And since that's negative, I'm going down to negative infinity. 2 pi is the exact same thing as 0. So at 2 pi, I'm also going to be at +1. Okay, and then you need to be careful that you don't start like shooting weird things, all right? We got to have this side. Now, I don't need to do the other half because I only went to 2 pi, but you could if the graph went further. And then just like with pi, at negative pi, I'm going to be over here at -1, and I need to shoot down to infinity. Alright, so just like with tangent, at every asymptote, you should have one side going to positive infinity and one side going to negative infinity. And then last but certainly not least, we need to have cotangent. Alright, remember cotangent is the same thing as 1 over the tangent of x. So we can go ahead and graph that. Again, I'll only go out to negative pi, but we could go further. Okay, and we're going to have an asymptote anywhere our denominator is equal to 0. Well, tangent is equal to 0 at, let's see, tangent equal to 0. Tangent's equal to 0 anywhere sine is equal to 0. So, oh yeah, we also could write this as cosine over sine. Right? So this is equal to 0 anywhere that cosine is equal to 0. So that's going to be pi over 2 and 3 pi over 2. I'm sorry, I'm putting asymptotes. Oops, my bad. Sorry about that. So, cotangent is equal to 0 anytime cosine is equal to 0. Cosine is equal to 0 at pi over 2, at 3 pi over 2, and we could be at negative pi over 2. There we go. All right, and it's undefined anytime we have 0 in our denominator. So anytime sine is equal to 0. Sine is equal to 0 at 0, obviously, at pi. So here are our asymptotes. And at pi over 2, because that's the same as 0. And over here at negative pi. And don't have this shooting up like this, because that's what tangent looks like. We're doing cotangent. So we're actually going to do the opposite. Okay, so when tangent, we would have been shooting up there. For cotangent, we're going to shoot up the opposite way. So cotangent is going to look like this. Alright, so there is the graph of y equals cotangent x. Very similar to tangent, asymptotes are in a different place, and it goes the opposite way. And that is it. Those are the graphs of your reciprocal function.